code and hopefully help out with some debugging as well, some debugging approaches. So I'm going to start off by just compiling this code. So gcc minus wall q3. Oops, let me save this. I'm having to do this again because the first recording I made didn't have any sound. So let's try this again. Okay, so now we've got the code. And we have several errors and warnings. So I'm going to start off at the top, as I always do. And the first warning is that the address of the stack memory associated with local variable is returned. So what it's complaining about here is that new DNA is a variable on the stack, which means that it only exists within this function. So as soon as this function returns, whatever new DNA refers to doesn't exist anymore, which means if you try to access it from main, it's going to potentially, well, it's undefined what will happen, but potentially is going to segfault. Either way, that memory is no longer valid. So the way that we avoid that is that anything that we want to exist outside of this function, we have to return it. And if what we're returning is a memory space, it must be heap memory space, because stack memory space does not persist. So rather than making it a stack variable, we need new DNA to be a heap variable. And we want it to be, well, whatever the sequence length is, times the size of a char, because that's what we're storing in it. Okay. Now, if we wanted to make this a string, obviously we'd need a sequence length +1 to lit space for the \0 character, and we'd need to write that \0 character in there. In your code, I notice you're not using it as a string, and that's fine. But if you did want it to be a string, then that's what you'd need to change about this code. All right, so that's fine, and then we're going through the sequence length, and we're checking to see if it's equal to the nucleotide, and if it's not, we're going to put it into our new DNA array, and we don't need this else because we don't want to print anything inside of our function, and then we return that new DNA. So now that it's on the heap, then the memory referred to by new DNA will still be around after this function returns. So main can look at it, which is what we want. So that will fix this first one. Then the next mistake is on line 35. It's going to be 36 now because I just added in a line. And it says that the format specifies a char star, but the argument has type int. And the reason is that, okay, the scanf says it wants a char star, a string. What is nucleotide? Nucleotide is just a single character, so it's not a char star. So if we basically want to store nucleotide, and I'm just going to move this variable down here, just so I can keep all of these things together. It's a little bit easier for me to keep track of my variable types. So I actually, and most people will say, declare your variables where you actually need them. You don't have to declare them all at the start. That can make it a little bit easier to read your code now. All right, so we have fixed that second warning. Now the next one, it says DNA sequence 1 has been redefined with the different types. So let's look at DNA. So there's a DNA sequence 1 here, and there's a DNA sequence 1 here. So you've got two variables. One's a character, and one is an array of characters. But what remove nucleotides returns is a char star. It's a pointer to the first character of a character array. So the right type for this is a char star, and we don't need another declaration for it. And indeed, this is not going to copy things. We only want an address because remove nucleotide, if we assigned this DNA sequence to it, it's not going to copy the values into it. It's going to try to change members. It's basically going to fail because you can't assign a pointer to an array. You can assign an array to a pointer because it just decays to the address, but you can't assign a pointer to an array. So DNA remove nucleotides returns a char star, so this should be a char star. So that will fix that problem. Yep, that's it. So let's try compiling this. Let me make sure I save it. Okay, so it's complaining about line 42. Oh, I didn't fix that nucleotide. Yes, so this is reading in a single character. Now, we don't want to insist that it has a space afterwards, so we don't want to put the space in our scanf. Remember, the scanf has to match. So if you say this, then the user has to type a character followed by a space. Otherwise, the scanf will fail. So leave it as, all I want to do is read the single character. Because it's a char, remember I have to take its address. And so that's looking okay. Now it compiled. That's good. All right, so that just means it compiles, doesn't mean it works. Let's run it. Okay, so it goes to remove nucleotide immediately and never let me type in the nucleotide that I want to delete. So what happened there? So obviously it got some value. So it skipped straight over this scanf. But it didn't actually skip it. It did call it. But it means that nucleotide, it didn't wait for me to type it in. So what could that be? Well, let's try printing out what nucleotide is. And I'll just put a %C in here and print out nucleotide to see what is actually being stored in that, because it just seemed to skip over that. Let's try that again. Okay, nucleotide is new line. So what it's done is it's read the GATTACA into your sequence, your DNA sequence, but then the new line character is still sitting on the input stream. So remember back when we looked at scanf. Scanf skips white space, being new lines, tabs, spaces, for all types except the character type. We're reading in a single character. That new line is being read in as the character. So that's why it's not waiting for us to type anything. So how do we fix that? Well, we say, look, first read the new line, okay, off of the input stream. And then the next thing you read is the character. So we always have to keep in mind what our input stream looks like, especially when we're working with characters. So we know that there's going to be a new line there that we've got to get rid of, and then the character. I just noticed one other thing. If our sequence is up to 10 characters, we better leave 11 spaces for the string because we need space for the \0 character. So don't forget to size that correctly. Otherwise, you won't be able to type in 10 characters. It'll cause it to fail. I also put in the 10 here to prevent this from overriding the end of the array. Okay, so that looks better. Now we'll basically read that new line character off the input, and then the next thing we read will be matched to the nucleotide character. So let's check that that works. Okay, that's at least better. It's waiting for me to type in something. I'm going to type in A, and it says the nucleotide is A. That's good. And G has one G. it's removed all the A's. It's got one C and two T's. So it looks like we're all working. So I'll stop that and save it here. What I suggest you do after following through this, just see if you can fix the code yourself. The last thing I'm going to do is take out my print statement. I'm not going to take it out. I'm just going to comment it out because maybe I want to use it again later. So hopefully that will help you through. But like I said, again, after watching this, please have a go yourself.